Okay, good afternoon, FOSDEM. My name is Maarten Hoogendoorn. I work for Container Solutions in Amsterdam, and I would like to talk for a few minutes about managing your dependencies in the containers we are building. And by managing your dependencies, I'm not just talking about your requirements.txt, for example, for your Python project, but also things like the libxml that you normally would get from your operating system, and linked in your Python interpreter, or even shelling out to Graphics. So typically this was done by your sysadmin by just apt-get installing everything until it somehow worked. That doesn't scale very well beyond one sysadmin, one program, and one server. So configuration management was invented to solve that. In essence, configuration management is installing packages, removing packages, and writing files. There are unfortunately two problems with this. The first one is that updates are not atomic and you can't undo any steps. These two problems cause configuration drifting over time, and they are solvable with workarounds, but it's not inherent to the model and it's quite hard to actually get right properly. So in the last few years we have seen that layer-based systems are becoming popular, and with that one I'm actually referring to Docker. And it promises to prevent these configuration problems. It basically boils down to that you have different layers that you can build that are immutable and can be stacked on top of each other to compose them. Unfortunately, this also has some problem. If you, for example, install two programs, program A and B, and then would update A afterwards, you would actually have to redo all your steps again, which can be quite expensive. The other thing is that people use it for build packs, so they would actually include your compiler in some step and then build your program and publish your image including your compiler to publish it to your production environment. You can solve this in different ways, but it's not again inherent to the model. So I would like to take a short break and see what we have seen so far. No management, the configuration management that's going linearly. Then we have the Docker images going in a tree shape. And the next logical thing to look at is, of course, graphs. It's the next complicated thing. And graphs do something differently. There you basically specify, you specify what you want to have declaratively. So I say I want to have a square and a triangle, but it doesn't really matter in which order I'm going to declare it to be in my container. You're pushing the composing of what's in your container until the very last moment, actually. So how would it look in practice? Let's say I'm having a state with both Vim and my application. That's the blue circle on the left top. And then we're going to take a detailed look at my application. And there are two types of dependencies. The dotted line denotes a build dependency, and the rest are actually runtime dependencies. So we have the graphics, the libxml in there, as we had in the original example, and then my application is apparently, in this case, built with Rust. It has source and creates build instructions. So we can ship just the runtime system to your container and to your production environment by default, because we make a distinction between the two types of dependencies. Conversely, we also have the very nice advantage that we exactly know the precise build environment that we have that you during your actual build, and you can create a runtime system for this during development, so that you will have exactly the same dependencies during development as during build. So to conclude, layers appear to compose pretty well, but actually they don't. Graphs do compose really nicely. And there are a few implementations. The one that I'm most familiar with is NixOS. Check out NixOS on Freenode. The other one is Habitat by Chef. And I accidentally discovered a build system by Google yesterday called Bazel, which is implementing exactly the same model, actually. So thank you very much for your time. And yes, that's all actually what I wanted to say. So thank you very much.